Hello students, today we are going to discuss about the solubility of gases in liquid. So we are going to do the chapter solution. We have already started the chapter solution of plus 2 chemistry, solubility of gases in the liquid. We also will discuss about the Henry's law in the chapter in this video. Okay students, so we will start with the solubility definition. So what is the definition of the solubility? Solubility is the maximum amount of the solute which is dissolved in the specific amount of the solvent, So what you can say that if you have a solute molecules and it is a solvent, and when we add the solute, so you must decide the how much solute is going to be added in the specific amount of solute amount of solvent, so that you can make the solution. So this is called solubility. What is this called? Solubility. So how much you are adding the solute in the specific amount of the solvent is called solubility. So next you can see that there is a it depend upon the following factors. Which factors which are controlling the solubility of a gas in liquid. So there are few factors: nature of the gas and nature of the solvent. These are two important factors which are responsible for the solubility of gas and solvent with each other. So if the gases are more easily liquefied, they are more soluble. So more easily liquefied gases are more soluble. So we have to check that gases are more soluble, more liquefied, and then they will be more soluble. We have to say that if they are easily liquefied, then they are more soluble in the aqueous solution. So you can also check the effect of the temperature. So there is also a effect of the temperature, you can see, but before watching that, we have to consider one more factor. What is the one more factor? There is a ionizability. Ionizable gases are also more soluble in solvent. Okay students, so next factor, which is also important factor, effect of the temperature. So with the increase of the temperature, the solution is heated. If you can say that I am going to heat the solution, then the solute particles will escape out. You can think that there is a solution, there is a solvent plus solute. If we are increasing the temperature, we are giving the heat, so we are heating it, then there will be solute molecules which will escape out. So this means that solubility is decreasing. Okay students, so there is another effect, but there are some gases which are soluble at the higher temperature especially we can say that non-aqueous solutions, in the non-aqueous solutions such as acetone and benzene, such as acetone and benzene. So we will discuss the effect of the pressure on the solubility, which is also related to the Henry's law, which is also related to the Henry's law. So we can say that generally with the increase of the pressure over the solvent, molecules are more soluble in the solvent to form the solution. If we increase the pressure, you can say that we have solvent molecules, and there are molecules of the solute. When we increase the pressure over here, so P is the pressure increasing, then there will be the solubility increases. Solubility of gas molecules increase in solvent. So there is a main factor which are responsibility of the solubility of gas in liquid solvent. So there is a Henry's law which is related to the pressure. So we can say that Henry's law, the solubility of gas so in liquid, which is directly proportional to the pressure of gas in equilibrium with the liquid at the room temperature. So what we have to consider, the things you have to consider, that x is the mole fraction, of gas, and kh is Henry constant. Generally we say that Henry's constant. And there is another factor which is called P. P is the partial pressure. Of the gas. So you can say that P is the partial pressure of gas. So by the relation you can say that P is equal to kh dot x. Okay, I told you x is the mole fraction of the gas, P is the partial pressure of the gas, and kh is the Henry constant. So there is a relationship between the partial pressure, mole fraction, and Henry's constant. So there are factors: mole fraction of gas in the solution, kh is the Henry's constant. So these are the factors which are responsible in the Henry's constant at the some pressure. So there is a values I told you already, that kh is the Henry constant, which depend upon the nature of the gas. So there are different gases behave differently at the same temperature. So x I told you is the mole fraction, and P is the partial pressure of gas. So I want to tell you what is the partial pressure. Partial pressure, if you think that there are number of gases present in the solvent, you can say that A, B, C, there are different three gases, then we have to check only the pressure of A, which is called pressure of A. So in the solution, if only there we are talking about the pressure of A, that is called partial pressure. So partial pressure, that mean that we are talking about the pressure of one component in the liquid about the. So there are three solute, you can say that there are three solute in the solvent, but we are going to check the pressure of only gas A. So you can see that there is a one example about the P and X. So P is the, I told you, partial pressure, X is the mole fraction of gas. If we draw graph between the partial pressure and mole fraction, you get the straight line graph. So this means that partial pressure is directly proportional to the x mole fraction of the gas. So we have taken the particular example of HCl in the solvent cyclohexane. So there is some conditions for Henry's law which are important. So if we check that pressure should be should not be very high. Pressure should not be very high. If you give the too much pressure, there will be the interaction between the solute and solvent. Then there is a solute and solvent molecules interactions. So with the interactions, there will be no applications of Henry's law. The temperature should not too low. If we make the temperature too low, then there will be no movement of the solute particles in the solvent, so there will be no formation of the solution. The solution of gas in the solvent should not be very high. The solubility of the gas in solution should not be very high. If there will be the solubility of gas in solution is high, then there will be the interaction, association and dissociation will take place. If there will be the association means that there is a combination of the solute and solvent molecule. There is an interaction between the solute and solvent molecule will make the Henry's law unapplicable. So there should not be a dissociation. Dissociation means that if you think that there is a HCl, if we add HCl in the water, then there is a one condition happens that H positive and H3O positive. So there is a case of dissociation or association. So you can say that there is a case of dissociation. Dissociation means that there is a formation of ions. There will be a formation of ions. H3O, there will be a formation of hydronium ion and chloride ion. So this process is called dissociation. So dissociation happen if there is an interaction between the one water molecule with the HCl, which is acting as the solute. This is acting as solvent. Okay, students. So there are important conditions for the Henry's law. So next we see that applications of the Henry's law, which are very important from the point of exams. So solubility of carbon dioxide. If you see that there are Coca-Cola or there are some soft drinks which are available in the market, they having the carbon dioxide too much. They having the carbon dioxide with the increased pressure in them. When we open the bottles, then solubility of carbon dioxide decreases, which comes out the bubble, comes out as the bubble. So oxygen, another important factor is the oxygen in the lungs. So there is a high partial pressure of the oxygen in the lung. So that's why oxygen they get attached with the hemoglobin molecules. Hemoglobin molecule, which form the oxyhemoglobin, So by forming the oxyhemoglobin molecule, they get carried to the blood, which get carried to the different organs of the body for the respiration process. So there are scuba divers. What are scuba divers? The persons which go under the ocean or sea water for the research or other things. You can say that there is a water pressure of the water increases when they go inside the ocean. When the divers go inside the ocean, there is a too much pressure of the water over their body. The solubility of gas increases in their blood. with the solubility increases in their blood. So when they come out, then the solubility of gases decreases due to decrease in the pressure. Due to decrease in the pressure, the solubility of gas decreases. So when the nitrogen coming out from their blood, at that time they block the capillaries. When nitrogen coming out from their blood, which is present in the oxygen cylinder, they cause the painful problem which is called bend, which the problem is called bends. To avoid this problem, oxygen gas cylinders are filled with the helium. So helium what do? Helium decrease the concentration of the nitrogen. So at the place of too much nitrogen, helium which is non-interacting gas, so it is also filled in the oxygen cylinder, so that N2 nitrogen gas concentration decreases and protect the scuba divers from the bent. So at the high altitudes, when we go up on the high altitude, there is a when we go at the high altitudes, so on high altitude like altitude pressure, partial pressure of gas, partial pressure of oxygen decrease, of O2 decrease. So when they breathe, there is a less oxygen go into their lungs. There is a less oxygen go into their lungs, which cause the weakness and unable to think. Okay students, these are applications of Henry's law. So there is a one numerical which is based on the Henry's law. So you can see that a gas, H2S gas, having solubility of 0.195 m at STP. STP is standard temperature and pressure in aqueous solution. So calculate the Henry's constant. Henry constant, you have to find KH. You have to find the value of KH. The solubility of H2S in water is 0.195 m. This means that the number of moles of H2S is 0.195, because we are talking about the number of moles. So the solubility means that number of moles present in the 1000. 0.195 moles in 1000 water, in 1000 ml of water. So you have found that there is a number of moles. Means that N2 you have found, but you also have to find N1. N1 is the water. It is a number of moles of water. So we have to find the number of moles of water. Here the weight of the water is 1000, and we know that molar mass of water is 18. So there is a 55.55. Now you have two values, N1 and N2. You can also find now you can find X2. What is X2? X2 is the mole fraction of H2S gas. By applying the formula N2 divided by N1 plus N2, you can find the value of X2. So you can find the value of X2. So here we have found the value of X2. So mole fraction of H2S gas is 0.0035. Now we have found the value of XKS. So H2S is given, partial pressure of H2S gas is already given, which is 1.01325 bar. Okay, now you can find the value of KH. Now you know the two values, this value and this one value. So then you can find the value of KH. Now you can find the value of KH. So dividing two things, you will find the value of KH. Here the value of KH is 289.5 bar. Okay students, thank you very much for watching the video.